Alright, good deal, good deal. So, hope everybody's doing fine. I have a failed tutorial, so let me remove that right now. And what I want to do is, my goal is to create a network manager, okay? I remember in the other tutorials I went ahead and, with my LFS, I downloaded all the wireless programs I needed to access the internet and get into my router and everything else like that. And the network manager is massive, okay? And I could use YCD, which isn't as bad, but I figured why not just make one and kind of use the time to expand on how to do a little bit of scripting, okay? Scripting's important. They are programs. They're not the hardest programs to do, but they are programs, and they can be utilized and manipulated and done everything else like that however you want them to actually perform a use, a function, purpose. Okay, so your operating system is full of scripts and programs and scripts and programs. Okay, okay. And one we're going to talk about, what I'm going to do is I'm going to write a program in Bash. Okay, Bash stands for Born Again Shell. Okay, and it was made in the 70s or something like that. It's one of the more common scripting languages that is on the Linux operating system. Most mainstream operating systems. Some don't have Bash. If they don't have Bash, we can say which. I think I can do it this way. Which Bash. If they don't have Bash, they usually have SH or something, or even in Unix, or not Unix. Oof. I don't even know if you can call Unix anything. Even in Ubuntu, you would have something, maybe dash, okay, or ash is another one. KSH. There is a lot of shells, okay, and basically what a shell doesn't really get ran like a program or compiled or whatnot like that. A shell is noted for being quick and painless, okay. It reads line by line, okay. So that's why it comes in handy, and a lot of the stuff is for just quick access, easy access to little quick programs that really don't involve a lot of debugging or anything else like that. Okay, so and you can make a program within a program. Okay, and basically that's all we're doing. If we were to say echo high expletive, okay, if we were to do that, then that's what we would get. Well, echo is a program, okay, and we can also use bash to do that program, or do echo, whatever we want it to, okay. So bash is very, very useful. So let's go ahead, let's make a directory, sanitize it away from everybody. So we'll say netman. You want to kind of make it unique, that way if you don't want to name it something like network manager, okay, because if you ever did that and you actually did download a network manager, then it would either mess up your script or even mess up that script, and that's not really a good idea. So let's get into it. We're going to say vim netman.sh. sh is important. That signifies it's a shell. Although you don't need it, it's always good to have it. Okay? Good practice to do that. So let's say bash scripts start out with a lot of people call it the shebang, okay, which is just a pound exclamation and bin bash, okay. That's known as the file descriptor. This tells the operating system that this is a bash shell, okay, and that the syntax in here will be recorded as bash. So do that. Pounds signify comments, and when you're doing a script, scripts can get very long, lengthy in size, so it's always good to comment out some instructions, or maybe just how it's going to go together, flow, words, whatever you want to type in here. You know what I mean? It's kind of good to have comments in your code for debugging purposes, for you, or if you pass it on to somebody else, and just so you can actually know what's going on in the operating system, or when your program is being executed. I'm going to show you a script I made. So this is my first network manager I made for this computer here, and as you can see, this is pretty much how it all kind of goes together. Alright. There's some stuff in here that really doesn't work too properly, but I comment that out and I'll fix that in time. Bugs, if you want to call them that. Okay. But you can see all these comments here. You know, it just indicates what's going on and everything else like that. And it's always good to have those around. And you notice here that some comments are definitely needed when you get into something deeper like this. You know, where you kind of might not know what's going on. Right? It's always good to comment stuff out. And like I said here, start connection. You know, this is what's happening here, and this is what's happening here. Yada 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 yada. You know, so it's not a perfect program, but it works and it's good. So use your comments. So let's say I like to always put in here just a little comment to what this is. So I'm going to put just another network manager. Okay. And I like to put start and end. Once again, they're not needed, but just makes it kind of nice and tidy in case. It's just a good practice to do. Okay. So now within Bash, this is a shell. Like I said, it reads line by line. So basically what happens is, instead of getting compiled, operating system, when you execute this code, the operating system will say, okay, this is a bash shell, okay, recognize the bash syntax, and it reads next line. It's empty, it's okay, no operation, right? Comment means don't do, okay, or possibly no operation. Okay, I'm sure there's a more technical term than that. It's going to read that comment, read that comment, read that comment. So what this program should do is nothing. Okay, so we'll right quit. Anytime you want to execute a bash program, or if you have a script going on, you want to make it executable. Okay, so change mod +X and the name of the file. Okay, and now let's run it. Okay, of course there's nothing. Now, if we were to do something, like let's say we want to make it do something, so we'll say echo hi Bob. Okay. Now, if we .run it, this is the way you execute a bash program. ./ and the name of the file, or you could also say bash and the name of the file. Okay. Do that. It says hi Bob. Cool. Just what we told it to do. Now, if I were to take and comment out this line here, okay, stick a $sign in front of it, you'll notice when I run it again, nothing happens. Okay, that's just how the file executes. Right, anything with a $sign in front of it will not be executed. So that's good. And you can also use that for debugging purposes. You know, you can turn off specific programs within the file and stuff like that. Alright? So now we got something going to the screen. Cool. But let's talk about variables. if I was to say name, okay, and let's call the name Johnson. Okay, this is a variable. How do we know it's a variable? Not only because it's highlighted, but some programming languages will read variables as spaces in between equals and the value of the variable. Okay, in this case it's a string. Okay, but with Bash, no spaces. Okay, and you can change variables at any time. You can change it to, well, let me see. I'm going to echo out that, and I can then set name to be Peter, and then I can then say echo hi. It's always a good idea to encase your string, okay, words, inside of double quotes, okay, and also too, it's always a good idea to stop everything with a single semiquote or semicolon. Sorry. Alright, it's not needed in Bash. Right, it will just go to the next line. You won't get any errors on it, but if you're going to move on to other programming languages, it's a good practice to get that down. Okay. So now, if I say echo hi, let's say $name. Okay. And let's say hi $name. And I run it. See here, well, I got a little off on the spacing there, but we'll see here that it echoed hi Johnson, hi Peter. Well, what happened with that was, screw that up. What happened with that was, here's the variable. The variable holds a string value, and the string is Johnson. Okay. Bash comes and it reads this file descriptor, skips over no operation, okay, doesn't do the commented out lines, comes on here and hits this here. Well, it doesn't have a $sign or doesn't have a pound sign in front of it, so it's not ignored, and it has an equal sign attached to a string, so it's a variable. Alright. Then it comes down and it hits its first command, which is echo. Okay, echo what? Echo part of a string, which is hi, but it says echo a $name, or echo a variable. $sign signifies a variable. What variable? This variable right here. Okay, variable and the variable name. Okay. Now, if you notice too, after that got done executing, the program continued running. No op, and it hit the next variable, which happened to be name as well, but name got changed. Okay. And then it went ahead to execute the standard out, print standard out, or echo to the screen, hi $name. So variables can be changed according to the order that they're in, or according to the name that they're in too. That's understandable. You could name this one name 1, name 2, and it would have did the same thing, right? But I just want to show you that variables can change depending on the order and placement of where they are. Okay, or you can set variables, counters, for example. You know what I mean? Stuff like that. Right? So that's cool. That's enough on variables. Variables can hold values. Let's say we're going to leave the variable name as something. You have to declare your variable before you call it. Okay, so here it's declared, and here it is called. If you were to do that backwards, and say echo, let's not do that. Let's go ahead and just copy it out. And I'll put a comment here for testing. If you do that backwards, and you would first say echo $name, and then set the name equal to Peter, what you would find is, you get nothing. You got hi, okay, but you got no variable. The reason why is because you called it before you declared it. Okay, so it doesn't really work that way. Alright, cool deal. Doing a lot of echoing out to the screen, reading from input. We'll be doing a lot of that. Alright, it's essential to a nice little program. Let me change this here. One other thing we'll be doing is we can actually execute scripts within a program. Okay, or execute programs within our script, or execute programs within our programs. Okay, and we can assign them in a variable. And the way that we would do that, if we just typed in present working directory, I just want to find out what my present working directory is. Let me put a string here and say echo. You are currently here, and colon, yeah, why not? We are currently here, okay, and the $ name, alright, and right here I want it to contain present working directory. If I think that's going to execute, we recognize that that doesn't happen, okay, whereas here, type in present working directory and we get that. We get our present working directory. And this is the reason why. When this is attached to a variable, where the variable is assigned to the present working directory, in order to execute a program within this program, what we'd have to do is have to add the backticks. Backticks are next to the 1, alright? If you hit shift it would be a tilde, right? Backticks. You have it in case losing backticks. Okay, so now if we went ahead and ran it, we can say .run program name. It would say you are currently here. You can see here that it showed us our present working directory right there. Alright? So that's another useful thing we'll be doing. Okay, remember, case them in the tildes, and it will happen. We can actually string on a lot of stuff to this. We can say present working directory, cut with a delimiter of, let's call it backticks, or actually /, cut with a delimiter of / and field 2. Let's see what happens now. And we run it. We're currently in the home directory, okay? So you can see here that did present working directory. What it did was it did present working directory, and it cut with a delimiter of / and field 2, and this field 1 would be the first /, field 2 is everything after the first one. Okay, so that's what happened there. And see vim. How about cut with a delimiter / in field 4. Okay, and run it. And you see here it said desktop, because this is the first /, so home is in the second field, Doug is in the third field, and desktop is in the fourth field. Okay, so that's what you got there. Good deal, good deal. We'll be doing a lot of that. Let me cut this apart. Note the pipe. Okay, pipe is good. You can split. You can actually take the output of one command, okay, and modify it, which I did here. We'll be using pipes a lot too. We'll get into them. No big. All right, let's clean it up a little bit. And we'll do. Let's say, what I wanted to say is you are currently here. Now currently what happens is, when I execute this, it puts the present working directory on the same line. Okay? Now I could say something like echo the variable next in the new line. Okay? And that looks better, right? But I can also say put this all on the same line. Okay, I can put this all on the same line, but I can modify the echo command. Okay, and I can make it take switches. Okay, and the E would actually let me input escape codes, escape characters. Okay, for instance, the \n is an escape code, or escape key for a new line. Okay, or it might be carriage return, I'm not sure. Okay, T would be tab. Okay, and N would be new line, right? So now I can say right quit and netman run it. You're currently, and you see here that it dropped down to the new line. Okay, so we'll be doing a lot of that as well. Right? Echo E, Echo N does some other stuff like that, but that's that. That's that. So it's kind of important to remember the tildes, right? Use of variables, which we'll be doing. Definitely the use of tildes for calling or command or program within a program. Okay, and there will be some functions in here. I can get over functions real quick with you. They're really no different than variables. They can do a lot of things. Your whole program can be a function if you want to. Okay. And that's that. Let's say something like, just like a variable. Okay. We can make a function. Functions are, let's call this function namer. Okay. And the way to signify a function would be to encase it in parentheses, or brackets, I mean. Okay. Encase it in brackets. And then to open and close bracket, or squigglies. Okay. And since I'm going to jump over this, I can throw my squiggly down here. Okay. So basically what's going on here, program will get read, and it'll hit this here. My function will be called namer. It'll hit it. Notice it's a function because of the parentheses, or because of the parentheses, right? And you could hit arguments in here. Okay. I know with C and everything else like that, but with Bash, I'm not sure. I don't see why. I know you can. I think you can anyway. I have never used arguments in Bash though. Okay, so it hits this here, sees that it's a function, and the function is to do this inside of here. Okay. Well, now we don't have a variable, and that's okay. So I can show you what's going to happen next. If we run it now, from within here, we have the function, and we .run netman, nothing happened. And the reason why nothing happened is, even though we had a function, okay, it was defined here. There's no comments here, okay, but now this is going to expect a function, okay. So the function is pretty much initialized, right? But nothing happened to the function, okay. In order to call the function, you have to just say just the name of the function. Okay, and if we run it now, okay, it says you are currently here. Now you notice that nothing happened. You're currently where? Ignore this. Okay, you're currently blank. The reason why it's blank is because our variable name no longer exists. Okay, and so the string printed, which was you are currently here, the string and new line printed, but no variable came out. And we can change that by just saying something like name equals encapsulate there the output of present working directory. And for fun, let's just go ahead and throw a tab in here. Actually, I can put in, let's put in 2 new lines. 2 new lines and T for tab. Okay? So write it. What we should expect to happen. File descriptor, jumps over new ops, right? Hits here, says there's a function, right? These things are contained within the function, okay? And then it's going to hit call the function itself or do the function, okay? So then it's just going to read this stuff here. So let's see what happens. Right, quit, and let's run it. Okay, so it says you are currently here, 2 spaces, and a tab over. Alright, so we'll be doing some functions, and it makes life a little easier, especially when you're going to be doing repetitive tasks like we will be doing, sending down the interface, calling up the interface, checking here, checking there, storing files, writing files, making maybe say configuration, retries and stuff like that. So it's kind of good to, instead of having to type all this stuff out, okay, or even say, in the case of this script over here, having to type all this stuff out over and over and over again. I'm going to be using these quite a bit, so it's a good idea to maybe encapsulate them in a function. And just like the run down here, I set this up as a little section here where I can define my functions in the very beginning. This is my connection function, okay? It just sleeps a little bit, it tells you what it's doing, blah blah blah. And if I go down here to where I first called it, you will see that basically it's going to read, it's going to set my keys, give the user output, okay, set the key to whatever it's desired to be. In this case it's a open router, so the key is going to be off by default, right? And then it's going to hit the connection function. So this connection function is actually going to just do this. Okay, so instead of having to type all this down there, I can just, set it up as a function up here and just call it from down there. I have some other functions in here and got a lot of time. We'll go over every one of them. Okay, so that's what I got. Life is looking good. I really don't need to explain too much more about it. In the next one, we'll go over some stuff like some more syntax. So, cool deal. Catch you guys later.